Hello, my name is Principal Singh and I am Professor of Physics. Today we will study the motion of the particle under constant acceleration and the three equations of motion, and we will see how and when these equations are applicable for the motion of a particle. First of all, we will derive the first equation of motion. We know that the definition of the instantaneous acceleration is A equal to dv by dt. So if we cross multiply dt by dt, we get dv equal to a dt. If I will integrate this equation, let's say at t equal to 0, the velocity of the particle is u, and at time t, the velocity of the particle is v. On integrating on the left side, the integration of dv is v. We will put the limits like this. As we know that a is constant, the a is not depending upon time, a is always constant, a is constant throughout the journey. So a will come out from the sign of integration and the integration of dt will be t. So we get a t from the limits 0 to t. On putting the limits, we get v minus u equal to at. This implies v equal to u plus at, which is a well-known equation. V equal to u plus at, the first equation of motion. This equation is applicable only when we know that the acceleration of the particle is constant. It is moving under constant acceleration. V is the instantaneous velocity, that is the velocity at the instant t, at any time t. This formula gives us the velocity. U is the velocity at t equal to 0, that is at the starting of the motion, or when we are considering the motion at t equal to 0. Second equation, ds upon dt is equal to v. This is the instantaneous velocity, the definition of the instantaneous velocity. If I will cross multiply with dt, we will get ds is equal to v dt. I will put the value of v over here. So what we get is ds is equal to v is the instantaneous velocity. So we get u plus at times dt. Now we will integrate this equation also. At t equal to 0, let's say the position of the particle is s0. At time t, the position of the particle is s. Now when you will integrate it, you will get s minus s0 equal to ut plus half at square. If we say that at t equal to 0, the particle is starting from origin, so we can say that s0 is 0. So then this becomes s is equal to ut plus half at square. This is the second equation of motion. Let's see how to derive the third equation of motion. The acceleration is also written as a equal to v dv by ds. Here we have written a equal to dv by dt. If we will multiply and divide by ds in the numerator and the denominator, then ds upon dt will become v, and the equation will become v dv by ds is equal to a. Now cross multiply with ds and we will integrate this equation. At s equal to 0, when the particle is starting, let's say the velocity of the particle is u, This is the initial velocity. When the particle has travelled s, when it is displaced by s, the velocity of the particle has become v. On the left hand side, on integrating, we will get v square minus u square by 2 equal to as. A will come out from the sign of integration because it is constant. So we get v square minus u square equal to 2as. So v square equal to u square plus 2as. If the particle is retarding, that is, the speed is decreasing as the particle moves, we will use v square equal to u square minus 2as. And this equation tells us that v square equal to u square plus 2as, that is, the particle has the acceleration, it is speeding up. We see that the velocity and time relation is linear. So the velocity time graph of the particle will be a straight line like this. This is the velocity at t equal to 0 because v is proportional to t, and the slope of vt graph gives us the acceleration, the value of a. If we draw the graph of s and t, we will get a parabola. At t equal to 0, s is 0, so the graph will be a parabola. Now what type of parabola it is? If a is positive, in that case the parabola will be facing on the up side. So the graph of ST will be like this. Today we will discuss numericals in kinematics, that is numericals in motion in one dimension. Here is a numerical. A car starts from rest at a constant rate alpha. Then for some time it continues that same acceleration, after which it decelerates at the constant rate beta and then comes to rest again. If the total time elapsed for this whole journey is capital T, then we have to find out two things. The first is maximum velocity attained by the car during the complete motion, and second is the total distance travelled by the car. So first of all we see that, let's say this is the straight line in which car is moving. A is the starting point, and from A to B the car is accelerating at the constant rate alpha. It has started from rest, and then when it reaches point B, the car applies the brakes are applied on the car, and then it starts decelerating, and finally it comes to rest at C. So how to find out the maximum velocity? First of all, when the car is accelerating from rest, its velocity is continuously increasing up to B. Then at point B, brakes are applied and the velocity decreases. So it means that the velocity is maximum at point B. So we have to find out the velocity at point B. For that, let's say time taken from A to B is t1 and from B to C is t2. So now, using the first equation of motion, the initial velocity at A is 0. I will use v equal to u plus at. The initial velocity at A is 0. The time taken from A to B is t1, and the final velocity at point B is v max, the maximum velocity. So if we apply this, we get the velocity at B is Vmax equal to 0 plus alpha T1. Now the brakes are applied at point B and it speeds down, the speed decreases and it comes to rest at C point. Again I will apply the first equation of motion from B to C. The initial velocity at B is Vmax and the final velocity at C is 0. So again applying V equal to U plus AT for B to C part. So the final velocity is 0, the velocity at C, the initial velocity is Vmax, the velocity at B, and the time taken from B to C is T2. So 0 equal to Vmax minus beta T2 because the deceleration is beta. So we have to put a minus sign here. From here, if I find out T2 equal to Vmax upon beta, and from this equation it is T1 equal to Vmax by alpha. Now it is given that the total time elapsed is T. So T equal to T1 plus T2. Now if I put the value of T1 and T2, I get the maximum velocity in terms of the given quantities, that is alpha, beta and T. This is the first answer. Now let's find out the total displacement of the particle, of the car, from A to C. From A to B, it has travelled S1 distance with the acceleration alpha, and then from B to C, it has travelled a distance of S2 with the deceleration beta. So we will apply the third equation of motion, which is V square equal to U square plus 2as or V square equal to U square minus 2as. The plus is in the case when the car accelerates and minus is in the case when the car decelerates. So here initial velocity, this is the initial point from A to B. So the velocity is 0. The velocity at B is Vmax. So Vmax square equal to 0 plus twice alpha S1. Now this is AB is equal to S1. Now this is travelled as S1. So S1 is equal to Vmax square upon twice alpha. In the same way, I will apply the third equation from B to C. B is the starting point and C is the ending point. The velocity at C is 0. The velocity at B is Vmax and the deceleration is beta. So again applying V square equal to U square minus 2s in this case. Why? Because it is deceleration. So it is 0 equal to Vmax square minus twice beta S2. S2 equal to Vmax square upon twice beta. If I add these two, S1 and S2, I will get Vmax square by 2 common under bracket 1 upon alpha plus 1 upon beta, and putting the value of Vmax from here, we get the distance travelled by the car is half alpha beta upon alpha plus beta into T square. We can do this question by the graphical method also, that is by drawing the velocity time graph. So this is velocity on the y-axis and this is time on the x-axis. The car is starting from rest at constant at alpha. It means that the graph will increase and will come to maximum and then it will decrease. Why? Because the velocity is decreasing. The slope of Vt graph gives us acceleration and this is Vmax. This is T1 and this is T2. So the slope is Vmax upon T1 equal to alpha. In the same way, Vmax upon T2 equal to beta. From here you see that T1 is Vmax upon alpha and T2 is Vmax upon beta, just like here. Adding T1 and T2, we will get again this relation from the graph. And if I find out the area of this triangle, the area of Vt graph, this gives us the displacement, that is half base into height. Base is T1 plus T2 and it is Vmax. The height of the triangle is Vmax. Putting this value over here and this is capital T, we will get the result. S is equal to half alpha beta upon alpha plus beta into T square. Today we will discuss a problem in kinematics, that is the question in motion under gravity. A balloon is ascending with velocity of 12 meters per second. When it is at height 65 meters from the ground, a packet is dropped from it. We have to find out the time after which the packet will hit the ground. Here is the figure. Let's say this is the ground and the balloon is rising up. When it reaches the height of 65 meters, a packet is released from it. The packet is released from the balloon. That is, the velocity of the packet which is released is equal to the velocity of the balloon. Then the balloon rises up with the same velocity, 12 meters per second, but the packet which is released from here, initially when it is released, it is also the same velocity as that of balloon, but now it is attracted by the gravitational force, so due to which it decelerates. It has got the acceleration due to gravity which is directed in the downward direction. So the stone which is released over here, it has also got the velocity of 12 meters per second right at the moment when it was released, but it was acted upon by the gravitational force, the gravitational pull of the earth. So it has got the acceleration in the downward direction which is working as deceleration over here. Then the particle slows down, it reaches at the top over here. At some height from this point, it comes to rest and its velocity becomes 0. After that, it will fall down again. So it goes up like this and then it falls down back again and reaches the ground. So we have to find out the total time taken by the stone or the packet when it reaches the ground. This is the starting point. Let's say the velocity at this point of the particle is 12 meters per second with respect to ground. The particle goes up and comes down. This is the starting point and this is the ending point. So the displacement of the particle is 65 meters in the downward direction. We will apply the second equation of motion, which is displacement equal to ut plus half at square. Now this is a vector equation. It is very important of the vector equation is that we have to take the signs also. So I have taken upward direction positive and downward negative. Someone can take upward negative and downward positive. It will not affect our result. So the displacement of the particle when it starts from this point and end up to this point is 65 meters in the downward direction. So we have to write down displacement equal to minus 65 meters. Then the initial velocity, the velocity at this moment, is in the upward direction. So u equal to plus 12 because it is in the upward direction. The acceleration of the particle is always vertically down, whether it is going up or it is coming down, it is always in the downward direction. So the acceleration throughout the motion is 10 meters per second square in the downward direction. The downward direction is taken to be negative, so a equal to minus 10 meters per second square. So when we put the value over here, we get minus 65 equal to 12t plus half a is minus 10 t square. This is a quadratic equation. So we have to solve this quadratic equation, which is t equal to minus 12 minus of minus 12 plus minus root of minus 12 whole square minus 4 into 5 into minus 65. On solving this, we get the two values of time. We can take only positive sign because negative sign is not admissible here. It has no significance over here in this question. So on taking positive sign, we get 5 seconds. So this is the time taken by the stone or the particle to hit the ground. Today we will discuss a problem in kinematics in one dimension. First of all, we will discuss a concept of displacement of the particle in the nth second. So what do we mean by nth second? Let's say the particle is moving in straight line and A is the starting point, and it moves from A to B, and at B the time is n minus 1 second, and at point C the time is t equal to n second. The displacement of the particle from A to B is displacement of the particle in the first n minus 1 seconds. In the same way, the displacement of the particle from A to C is displacement of the particle in the first n seconds. In the first n seconds. So we write down Sn, the displacement of the particle in the first n seconds, which is equal to, by the formula ut plus half a t square, we have to put small n in place of t, so un plus half an square. In the same way, the displacement of the particle in the first n minus 1 seconds, which is un minus 1 plus half an minus 1 whole square. The displacement B to C, over here you see that n minus 1 seconds are completed and the nth second is going to be started at point B. So from point B onwards the nth second has started, and up till point C the nth second is completed. So B to C is the displacement in the nth second. So it is given by Sn. We will write n in suffix. Sn represents displacement of the particle in nth second, and this is equal to Sn, that is this whole, minus this much, that is Sn minus 1. On subtracting Sn minus 1, we will get u plus a by 2 under bracket 2n minus 1. So this is the displacement formula in the nth second for the particle in the uniformly accelerated motion. Now there is a numerical. A body start with velocity 9 meter per second and it has a retardation of 2 meter per second square. We have to find out the distance travelled by the particle in the 5th second. Sometimes distance and displacement are equal and sometimes they are not equal, and this is an example which shows this. If we write S5 as the displacement of the particle in the 5th second, and using this formula we get 0, that is u is 9, a is minus 2 because it is retardation, and then n is 5, the displacement in the 5th second, and it comes out to be 0. So the displacement of the particle is 0. Let's see how it has become 0. The particle is starting from point A and its speed is decreasing as it is moving towards B. At point B, the time t equal to 4 seconds is over. After that point, a point C comes, and at that instant it comes to rest. So from B to C, it has travelled a distance, let's say x. After C, it starts back towards A and it reaches a point D, which is again at distance x in the reverse direction. Hence you say that at point B the time is t equal to 5 seconds. So B to D, it is the time from 4 to 5 seconds, that is 1 second interval. So you see that the displacement in the 5th second is 0, which is coming from this equation. This is how we interpret the situation. That is, in the half second it has moved in the forward direction, and the next half second it has come back, hence the displacement has become 0. We can say this by using the first equation of motion, and let's see when the particle comes to rest. v equal to u plus at, this is the first equation, the velocity is 0 at t equal to 4.5 second. That is, at c point the time elapsed is 4.5 second. That is, from b to c it has taken half second. In the next half second, that is from 4.5 to 5 second, it has travelled the same distance but in the reverse direction. So if we will find out x, then the 2x, 2 times of x, will be the distance travelled in the 5th second, and again remembering that the displacement is 0 in the 5th second. So for distance travelled, let's say this is x and this is equal to the distance a to c minus distance a to b. The distance a to c is the distance travelled in the 4.5 seconds, the first 4.5 seconds, minus the distance a to b, which is the distance in the first 4 seconds. So x equal to s4.5 minus s4. So on solving this, using the second equation ut plus half at square, we get x equal to 0.25 meters, and this is 0.25 meter b to c, and c to d is again 0.25 meter. So the total distance travelled in 5th second is 2 times of x, that is 2 into 0.25 is equal to 0.5 meter. Thanks.